Hi and welcome to this screencast on loops. Today I'm going to give a short introduction to for loops and while loops, and I'm going to say a few words on loops versus vectorized computation. Now before we get started writing our for loop, let us first remind ourselves how we create a vector of consecutive numbers in R. So for example, to make a vector that contains the numbers 1, 2, 3, 4, 5, I can just write 1:5 and that will give me that vector. Now a for loop is something you can use to go through each element in a list or a vector and do something for each of them. So I can type for, and then in parentheses I have to type a variable name, for example I, in, and then a vector, for example 1 to 5. And what it will do, it will go through all the values from 1 to 5 and each time set I equal to one of these values, and then it will execute some lines of code which I can put here in braces. So whatever I write here is going to be executed for each of these values 1 to 5. So what I could do, for example, is to just print out I. So if I type print I, what my program is going to do now is go through each value. So first it's going to set I equal to 1, it's going to print out that, then it's going to set I equal to 2 and print that out, and so on all the way up to 5. So if I press source now, we can see it prints out the values 1, 2, 3, 4, 5. Now just displaying the numbers from 1 to 5 is maybe not so interesting. What we are usually interested in is doing some sort of computation inside our for loop. So for example, let's see if we can use the for loop to compute the sum of all the numbers 1 to 5. So one way to do that is to first define a sum, a variable called sum, and set that equal to 0. Like this. And now in our for loop, instead of just printing out the value of I, what we'll do is we'll take the current value of sum and add I to that. And then we'll put the result back into the variable sum. Right? So we basically update sum to be its current or old value plus I. And now just to keep track of what's happening, we could just print out sum here inside the loop. So when I run the code now, what the program does, it starts by setting sum to 0, and then it'll run through all the numbers 1 to 5, and the first iteration of this loop, I is going to be 1. So it takes the current value of sum that was 0 and adds I that was 1, so the result is 1, and it prints out that. In the next iteration of the loop, I is going to be 2. The previous value of sum was 1, so 1 plus 2, that's 3, and that's printed out. In the next iteration of the loop, I is going to be 3. The previous value of sum was 3 as well, so it adds 3 and 3 and puts that back into sum and prints that out. That's 6. Right, so and as this for loop runs, after running 5 times, it'll finish, and the final result is 15. So the sum of the numbers 1 to 5 is 15. If I don't want to have all these intermediate results displayed, I can just put the print statement out here outside the loop, and if I run the code now, it'll just do the computations and print the final value of the sum like this. So now it only prints out the number 15, which is the sum of the numbers 1 to 5. Now in the for loop, we had to specify a list of numbers to loop over. So we had to define this vector of numbers 1, 2, 3, 4, 5, for example, in advance, that we wanted to do some computations on. So sometimes we can't define in advance how many times we want our computations to run. And in that case, we can use a while loop instead of a for loop. So let's say I have a variable x that has the value 5. Now, instead of a for loop, I can use a while loop. So I type while, and now I need to specify a condition. So my loop is going to continue running as long as this condition is true. So I could type, for example, while x is less than 10. And what do I want to do? I want to execute one or more lines of code, which I write in these braces here. So if I just look at the code I have now, it basically says x is 5, and now I'm going to continue repeating this as long as x is less than 10. Right? So that's going to repeat forever if I don't do something to change x. So basically, inside my while loop, I have to somehow update x so that at some point x is not going to be less than 10, and then my loop can stop. Right, so one simple way of updating x could be to add 1 to it. So I can take my x and assign a new value, which is, sorry, I'll just write it like this up here as well. A new value which is the old value plus 1, right? So basically I update x by adding 1 to it, and just to keep track on what's happening, I can print out x as well here inside my loop. Now when I run the code here, I see it prints out the numbers 6, 7, 8, 9, 10, and then stops. Right, so let's go back and take a look at why it prints out those numbers. So to begin with, x has the value 5. And now my while loop says as long as x is less than 10, I'm going to execute these lines of code here. Right, so x is 5. Now I update x so it has its current value plus 1, so x gets updated to have the value 6, and I print out the value 6. That's the first one here. Now I go back and I check the condition again. So x is 6 now, so is x less than 10? Yes, 6 is less than 10, so I'm going to repeat my code again. So I update x becomes 7, and I print out the value 7. Then I go back and check the condition again. Now 7 is less than 10. Yes, it is. That's true. So I repeat the loop once again, and so on. And at some point x is going to be 9. So I check my condition. 9, that's less than 10. Well, that's true. So I execute this line. X get updated to 10. I print out 10. That's the last number we print out. And then I'm going. The loop will go back and evaluate the condition again. Now x is 10 now. Is 10 less than 10? No, that's false. In that case, the loop will break, and it will then jump out and continue executing whatever code is down here below. In this case, there's no more code, so the program stops. So in total, this program will print out the numbers 6, 7, 8, 9, 10. Now we've seen how we can use for loops, and we already learned about vectorized computations, so working directly with vectors. And actually, in many situations, you can solve a problem using either of these techniques, but the code is going to look quite different. So let me give an example. We've seen this problem before. We have a vector v, which contains some numbers here. And the problem that we're going to try to solve here is to compute the square of each of these numbers, but keeping their original sign. So the number -4, for example, we should compute the square, that's 16, and then keep the minus sign, so the result here should be -16. And for the number 1, for example, we should square that, that's 1, and there's no minus, so it's just going to be 1. Right, so how could we solve this using vectorized computation? Well, one approach could be to say, let's first take all the negative values in v. So all the values of v where v is less than 0. Now we can just say we want to update those. We're going to set their value to the value they currently have, squared, with a minus sign in front, because all the negative ones need to retain the minus sign. And now we can do the exact same thing with, just going to write it like this, with the positive ones. V of v greater than 0 are going to get reassigned to v of v greater than 0 squared, and now with no minus sign. And finally I can just maybe print out v to see what happens here. So when I run the code, I can see that it prints out the results. All the values are squared, and the sign is kept as the original one. Okay, so this problem can also be solved using a for loop. So in a for loop, what I want to do is then loop over each element, and then do an operation to each element. So first let me write a for loop. So I can type for. Now I'm just going to have a variable I that's going to be looping over all the numbers starting from number 1 and then all the way up to the end, which is the length of v. So I'm just going to type 1 colon and then length of v. And now for each element in v, I'm going to do something. So I can get out the current value of the element that I is pointing to by typing v of I. So I could say if v of I is negative, then I want to do one thing, and in that case I want to just set that to its current value squared with a minus sign in front. So that takes care of if it's negative. Else, and that's a positive case, I'm just going to set that equal v of I equal to v of I squared. Okay, so this is a different way of approaching this problem. So finally I can print out v, and we can see what happens here. Okay, so I just need to remember to actually just reset v after the first run here. Right, so now we see that the vectorized computation and the for loop produces the same result as it should, but the code looks very different. It's two very different solutions. So I just want to mention here again that there's also a very compact and nice vectorized way of solving this problem. So you can actually make a very simple solution by simply saying v is equal to the absolute value of v multiplied by v. So here the negative ones values here, this part here will remove that minus sign. So basically when we multiply together, we're just going to have one minus sign. So all the negative ones are going to keep their minus sign, and the other ones are just going to get squared. So in this case, well, let's try and run that. Oops. Try and run it and actually print out v. So in this case we see we get the exact same result in a very compact way. But in general, for loops and vectorized computations can be used to solve sometimes the same task, but sometimes for loops have an advantage, sometimes vectorized computations have an advantage. It sort of depends on sort of how readable the code is and how complicated the solution gets. So to summarize, sometimes a problem can be solved either using a loop or using vectorized computation. The primary reason to choosing one method over the other would be that the code should be as readable and easy to understand as possible. If you're working with very large data sets, very large vectors, then usually a vectorized computation is going to be faster than a loop, but you have to try that out and see if that is true in practice. If there's no sort of speed issue, then you should prefer the type of code that makes the code most easy to understand. And both for yourself and to make sure there's no bugs in the code, and also for someone who's going to work with your code later on.